Hello, everyone. The second presentation, which I'm talking about today, is related to MATLAB. So I have some material which include part one or part A and part B and part C. So I left some of the material in part B for you to study and tried actually to stress on some of the important topics uh, today. Some of them are the files and drawing. So starting from here, I would like also to continue talking about some operations on vectors and some operation on functions. So these are very important topics. So as we know from the first presentation, you can create a column vector of elements like this. So v equal 1 and then semicolon. So semicolon moves you to the next line, and then 2, then semicolon, and so on. And then you can call any element in that column vector by saying v of 3. So this will grab element number 3. Or you can create a volume of 6 element like here, and then you say v of everything. So that will produce same output result. So look here. If I defined this vector, just a second. Okay, so if I take this vector, okay, and try to identify it here, let's clear screen, and then something like this. Then what is v? This is v. If I say v of anything, that will give me the same vector. One would say, what does the column do? Actually, the column means everything. Let's say I'm defining a matrix like this, which is 1, 2, 3, and then semicolon 4, 5, 6, and then 7, 8, 9. Let's work with this matrix for a little bit. So this matrix A, if I would like to get the first column of A, so I can say A of anything and 1. So this will give me any row and column 1. So that will give me that. Okay, I can get the first this is the first column. I can get the first row by saying row number 1 and all the columns, because this will give me that row. And then of course I can move this to another vector. Let's say I'm gonna call this P, right? So now P will be including the rows of this vector. All right. So this is some of the features that we can grab from here. Uh, so also, as you said here, you can grab some of the values from that array, not all of the values, maybe some of the values. So if we have this is a defined element or defined vector here, something like this. So we here say RV, which is this vector. We need to get elements from 3 to 7. So element 3 is this one, 4, 5, 6, and 7. So I will get these elements. We can extract part of it. And also from A, in A, for example, if I would like to grab the first couple of columns, for example, so I would say A of, if I want to get the first couple of columns, okay, so it means I need all the rows and only the two columns 1 and 2. All right. So this way you can manipulate data as needed, right? So maybe you can have, in some of the cases you might have a long data set consists of like input and output, let's say X and Y, and you would like to build a relationship. You would like to extract column 1 as X and column 2 as Y, and then you do the kind of operation you want on every single vector. So you can transfer the matrix to set of vectors. So that's possible. All right. And here, okay. Yes. Okay. Now the next step is addition, subtraction of vectors. You can do addition and subtraction of vectors. These are some of the examples that we can discuss here. So when you say clear all, of course it clear everything. CLC, clear the screen. Clear all means clear all the variable in the memory. So here we define A as a vector of 5 elements, 7, 11, 15, 23, 9, and B is the same thing. You can add the two vector and put the result of addition on another vector. You can subtract the two vector and do the put the subtraction result in another vector. Okay, also you can multiply the whole vector by a scalar value. That's again is possible, right? And you can also get the transpose of a vector. So if it is a row vector, it can be converted to a column vector. All right. Now, what other operation we need? We can concatenate or append vector. What does this mean? It means if you have a vector like R1, which consists of 1, 2, 3, 4, and you have R2, which consists of 5, 6, 7, 8, then you can concatenate the vectors like one after the other. So the R here will be consists of 1, 2, 3, 4, and then 5, 6, 7, 8. So the 1 times 4 vector will become 1 times 8 vector. Or you can put it this way. You can put the first row and then the second row. In this case, you are building actually a matrix of size what? Do you know what is the size? The size will be 2, because it's going to be 2 rows times 4 columns, like this. Okay, here is the result. 2 rows and 4 columns. All right? So this is the result of the operation that we uh, are doing here. And the same thing here. Let's look at this one. So here you are creating a column vector, which is 1, 2, 3, 4, and a column, another column vector, C1 and C2, 5, 6, 7, 8. And then when you say C equals C1, semicolon C2, so you are concatenating them one after the other. So this will be the result. If you did it this way, like comma or a space, so it will become like another matrix of size, in this case 1, 2, 3, 4 times 2. All right, so please try these experiments and you will see the result. Also, you can do some kind of operation on the arrays, like you can multiply. This is called a dot product. So a dot product means you multiply the corresponding element of the first vector with the corresponding element of the second vector, and the result will be the size. The result will be a vector of the same size as any of the two vectors. All right. You can also sum all the elements of one vector. So when you say sum SV, so if V consists of 3 elements V1, V2, V3, then sum SV will become SV of 1 plus SV of 2 plus SV of 3. And you can get the square root of all the elements in one vector. So this is an example. Okay, so you can try these examples here if you like. Now you can try this if we take this here. Okay, this is the result. Let me do CLC, clear all, and then insert this, and then we say who. Then we have V, so this is V, and then SV, this is SV, and which is SV here is V dot V, right? This is, by the way, this is one colon 2 to 20. So this is, you are creating a vector here with the start, the step, and the end. And then you get the square root and of it, which is going to be meg. This is the square root. Okay. For V, you can say sum of V. It will be 100. All right. So this is just an example of so this is sum of V, because here I'm taking dB is sum, which is a sum that we got from all the elements, which is 100, and then we get the square root of it. All right. Now there is also something called dot vector product. So the dot vector product actually will produce here an element. Okay, so if you try this one, okay, which is called dot product, we say dot V1 and V2, so it will make the multiplication and create the addition. Right? You can say him dot like this. You can see more details about the dot. I mean, some of this feature you might not use, but it's visible. So dot here is doing what? It takes the transpose of the first vector and multiplied by the second vector. All right? Takes the transpose of the first vector and then multiplied by the second vector. So this is a kind of operation you might need. So here you take the transpose of this one, so it becomes what? It becomes 2, 3, 4 as a vector. And then you have 1, 2, 3. All right? So that's the kind of operation that is implemented. Okay, if you want to try it, if you say who, now you have V1, so if we say V1 transpose, that's going to be V1 transpose. And this is V2, it's a row. So if you say V1 transpose and then you have it multiplied by here like this, multiplied by v2. So like this, that will be a matrix result, right? Oh, it should return a scalar vector. Okay, just a second. For n the array A and B returns a scalar product along the first non-singular dimension. Yeah. So here, what did we say? We say v1 and v2. So this is a dot product. So if this is a row, so we need to get this is going to be a matrix. That's a very interesting thing. So v1 and v2, right? We say dot v1 comma v2. That will give me a dot. So this should be transferred if we would like to get this as a dot. So v1 should be 1 times 3 and v2 should be 3 times 1, right? So one of them, so v1 dot v2, that's a vector, right? But v1 is size v1 is 1, size v1 is 1 times 3, that's correct. And then v2, size v2 is 1 times 3. In order to get this as 1 times 1, so it has to be v1 times actually v2 transpose. That's what it should be, right? Let's look at in details here. Dot returns the scalar product of vectors a and b. A and b must be vectors of the same length. When a and b are both column vectors, dot AB is the same as, oh, okay, when A and B are column vector, but when they are row vector, returns a scalar product of the vector A and B. A and B must be vectors of the same length. When A and B are both column vector, dot is the same as, okay, this is the only condition when they are column vector, but here they are row vectors, right? For dot A and B for NB array, so it's going to be different, right? So here this is if they are column vector, are both column vector, this will produce a result like this, but they are not column vector, right? Maybe if I say V1, let's say V1 equal V1 transpose, so it will be column, V2 equal V2 transpose, that will be column. If I say dot V1 comma V2, it will give me that results, right? But I mean, maybe you don't need this one, but at least you might need some others. Okay, this is a kind of another type of operation. Yes, display and display. Okay, actually I want, so this is how the matrix looks like. So this is, by the way, this is when I say it's A00 in MATLAB, there is no 0, 0. In MATLAB, it's always 1 and 1. So the index starts from 1. I'm just giving you this as an example to figure out how to call the elements. Now, concatenation of matrices. Yes, you can also concatenate matrices as you can concatenate vectors, right? That's also another option. And this is, yeah, here you see you can multiply these elements together. So you multiply one time, so you multiply these two matrices together. So what do you do in multiplication? You multiply 1 times 5 plus 2 times 7. This will get you this first element. Then you multiply 1 times 6 plus 2 times 8 gets you this element, and so on. I think this is a normal product, as all of us know. As we said, there are some sort of special functions like sort. In this case, if you sort a matrix, it will sort every single column by itself. Actually, I would like to go to the functions. Yes, function is very important in MATLAB actually, and it helps you to do some sort of operations that is really successful. So here we are still on my program. Okay, if I would like to open, I can say new function. If I would like to create a function that can be called. So if I say new function, this is what I'm going to get. And then maybe I can say save this function as, okay, I need to name the function. Let me first name the function here. I can say add multiply, for example. Okay, and I have two input argument here. Let's say it's A and B. All right, and then I have two output here. Let's call them added and or multiply. Multiply. All right, and then we can play with this argument here. Okay, now if I say save, in this case save as, I will get the name of the function, add multiply. All right, and then I can save it. So I'm gonna create also a main file here. Okay, let's say in that main file I'm gonna call. Let me try this. This is probe one. Okay, I will try to take this as Control C, and then I will call this main. Control V. I'm gonna read file save as. I will call it main. Okay, this is like our main program. Okay, so here I'm gonna collect values from users called A and B, and then I'm gonna use this function add multiply. So what I'm gonna do here, I'm gonna collect values coming from as input here A and B, and then produce this out. So in this case, I want to say, let me call this for easy like y1 and y2. Just it doesn't make any difference if you call it anything. So I say y1 equal A plus B, and y2 equals A times B. All right. So this is a function. I'm calling it simply. You have to say function, and then you define the output, and then you define the input. That's coming the name of the function, and then the inputs. Okay. So in this case, I can take a copy from this. Okay, and then I go to main. All right, and I can paste this here. By the way, for not to get confused, let me call this x1 and make this x2. Okay, so because there is a difference between the local variable and the global variable. Of course, MATLAB will not have any problem if you call it A and B, but just for simplicity reason. And then we can call this Z1 and Z2. All right, and then we would like to see if this would work. Okay, so what's going to happen here? If we execute this program the first time, I will get the first number, and then I get the second number, and then the result will be passed here to the add multiply x1 and x2. Then it will go to here, will go to this program, and then the two numbers will be added, and the result will go to y1, and then y1 will be as an output, and then the result here will be multiplied, and then go to y2, and y2 will be out. So if I would like to run this program, I can use the symbol here run, or as I said, you can copy this and paste it, or you can mark this like this, highlight it, and then press F9. Okay, but I don't want to press F9 because it will, stop the execution of the recording. All right, so I will go here and then run. Enter the first number, let's say it's 10. Enter the second number, it's 20, and here is the result. Okay, so multiplying, adding the two numbers, 10 plus 20 will get me 30, and then multiplying the numbers 10 times 20 will get you 200. So this is a simple way of, presenting the output. And so this is a function that produce an output, but maybe you can write a function that just do some kind of operation like drawing or something. I'm going to show you something soon. All right, so that's the syntax statement. So you have the name of the function, you have the input variables, and then you have the output here. All right. Okay, so this is a function. This is a nice example function that calculates the maximum of 5 numbers given as input. So here you say the name of the function is my max, and then you pass 5 variables, and then you get the output as max here. So this is a function which is doing if statement. It's in presentation to a presentation B. You have more information about the control statements. I think it should be easy if you have a background in programming by Python or C++. That shouldn't be a problem. So here you can compare the first number with the second number, and then the third number with the, the best number of the first two, and you keep doing this until you have the best number of all. But of course, if you save these values in an array, then you say max of that array, then you will easily get the maximum number of that array. You can have some functions like here we call it anonymous functions. Like for example, we have a function here called power. When you say add x comma n, so you define x as a variable and n as the constant that is used, and then you say x to the power n. So it's like if this is x squared, x cubed, whatever, then you say result power 7 and 3. So this will get you the output result of here. Like here you see result 1, so it will be 7 to the power 3, and so on. So that's another way of creating anonymous function, and the next function we try to use this function. So you don't have to write it completely in a separate file unless you have number of commands. So this is like a passing a parameter. So anonymous function is like inline function in traditional programming language, defined within a single MATLAB statement. It consists of a single MATLAB expression and any number of input and output argument as needed. All right. So this is a nice example. Also, I encourage you to try to do it. This is a quadratic operation. So this function returns the roots of a quadratic equation. So it takes 3 inputs as a root of quadratic equation and produce the outputs. And remember something, you can have functions also inside the function. Like a function here, this is a couple of functions. So this function is calling this disk. So this function here. So you have the square root of b squared minus 4ac. So you can call this function from this function, right? So you can call concatenated function together. I'm sure when you try this type of nested functions, you will see, but because of time limitation, you will have the presentation so you can implement it easily. So here you are calling a function from a function and global variable. Yeah, global variable is very interesting thing that you can do. And let me just get you, how can we do this here? Now, x1 and x2 are variable. Let me return this as a and b, all right? A and b, okay? And now, instead of having this function, I don't want to have a passing parameter here. What I'm gonna do, I'm gonna say global a, b, semicolon. And then I'm gonna take this, Control C on the main, I'm gonna define this as global variable. Okay, and I'm not gonna have passing parameter here. All right, and so that's basically what I did. I defined a and b as global parameter, and then inside the function also I'm defining a and b as global parameter. And then when I run this, I have to enter the value for a and the value for b, and then I'm getting the same result. In this case, a is and b are seen by all programs in the files that has this command global a and b. Okay, so I want you to understand this, because in some cases we might need it, because we need A and B to be seen by all subprograms. All right, great. There is some also information about the data types and so on, and especially for imaging. But I really don't think we need to talk about this now. So this is like a conclusion for the part related to function, and then the next part I will talk a little bit more about the graphics and drawing in MATLAB. Thank you.